All right, welcome everybody. So what I want to do is cover a homework assignment for graphing rational functions. Now, I'm actually not going to get into much of the graphing portion of that because typically what I'll do is just go ahead and use Desmos or a graphing calculator, when we need to go ahead and graph. I will kind of explain basically when we are graphing, I will do exactly the same process that I'm doing here, but then what I'll do is I'll just create a table of values and choose points to the left and to the right of each vertical asymptote and then find those values. And then once I have enough points that I can go ahead and sketch them to get an idea of the shape of the graph. But for this really video, these first two we can sketch, but I'm not going to bother with the other two. I just want to kind of give you an idea of what you need to do to prepare for graphing, but really to understand, what are the asymptotes as well as the x and y intercepts of the graph. Now, as far as on this live stream, it is going to be a little bit, hopefully I'm trying to make it a little bit quicker than usual. I wasn't really planning on going live today, so I'm not going to really have time to answer any questions at the end, but glad to see some of you guys have already started joining in. So I look forward to definitely working with some rational expressions and learning all the important parts. But I just want to kind of give you guys a heads up because it is me and my wife's and my anniversary today. So we got to go make sure I get home. And I was thinking about, I'll do the video later tonight. Then I'm like, no, I shouldn't do the video later tonight. I should enjoy myself back at home. So I'm going to go ahead and work this rather quickly. But, if you have any questions about what I'm doing in this video or any of the problems, please make sure you let me know, catch them in on the chat. I will be happy to kind of respond on that. But as far as doing any kind of additional problems, I just don't have time today. Hence, I didn't even, promote the live stream at all. I just kind of went into it. All right, so let's go and get into the first example. You can see this is in kind of the form of the reciprocal function, which if you remember the parent graph of the reciprocal function is 1 over x. So therefore, this is going to have some transformations. However, I don't really like this written as the 2 minus x. So what I'm going to do is I'm going to rewrite this as 1 over negative x plus 2 minus 1. And again, I actually want to further refine this because what I notice is using my transformations of my parent function, let's put that over here. Up here, that's going to be, a over b times x minus h plus k. What I want to do is I got to make sure if I'm going to identify the correct transformation here of h, I need to factor out the b. So in here, you can see my b is a negative 1. So I'm going to do this one more time. Factoring out a negative 1, and therefore I'll be left with x minus 2 minus 1. All right, so now identify my transformations. Remember, h shifts the graph left or right, k shifts the graph up or down. It's also important to understand what the parent function is of the parent graph here. So just to do a nice little rough sketch, we have this little hyperbola. And the important thing about this, though, is there's a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So if I have asymptotes, right, at x equals 0 and y equals 0, then if I shift the graph 2 units to the right, that asymptote just got shifted 2 units to the right. So I can say my vertical asymptote is now at x equals 2 units to the right. My horizontal asymptote, right? So if the graph is now being shifted down 1, so now my horizontal asymptote is going to be at y equals negative 1. The next thing we want to do is identify the x and the y intercepts. And so just, a rule of thumb, we'll work on the kind of tricks as we kind of get to this. But the x-intercept is, remember, when y is equal to 0. All right, and for right now, the best thing we can do is just replace y with 0. Now you can say, well, we don't have y. Well, remember, f of x, this is for the function notation, but this can be replaced with y if we're talking about the x and y values. It's still the output value. So I'm going to replace that with 0, and then I'm going to go ahead and solve for x. Now I can keep this notation. That's fine. It's not going to be further help me out or be wrong in here. Now I don't want to show, let's see if I have enough room for my space. I think I do. So let's go and add a 1 to both sides. And by adding a 1, I'll be left with a 1 equals 1 over 2 minus x. Now here's an important skill that comes up a lot. You can see that we have x in the denominator. We got to solve for x. We can't solve for x when x is in the denominator. We got to get x out of the denominator. So to do that, what I'm going to do is I'm going to multiply by my whole denominator, which is 2 minus x. Now this is really important. What happens here is by multiplying by 2 minus x here, that now can apply the division property, right? These can now divide out, and then I just have 2 minus x times 1, which is going to give me my 2 minus x. And then that's going to equal to what's left over, which is 1. And now what I'll do is I will just subtract the 1, so that becomes 1, and therefore, and then add the x to the other side, or you could do it the other way. Either way, you're going to get x is equal to a positive 1. Okay, now to find the y-intercept, that is when x is equal to 0. So all I'm going to do in this case is just put 0 in for x. So we'll just put a 0 in for x, so therefore I'll have, I'm going to use y as my notation, 1 over 2 minus 0 minus 1. So y is equal to 1/2 minus 1, and obviously, hopefully you can get this as to be a negative 1/2, but this fraction operation comes up a lot, so just a reminder, guys, just get common denominators. Right? 2 over 2 is the same thing as 1. So by writing it as 2 over 2, though, I get common denominators, and you can see that's y is equal to a negative 1/2. Okay? All right. Now, the next thing in the next problem here in B is we could do the same thing. We could use actually the vertical asymptote test as well as identifying the vertical asymptote, but I'm going to relate this, what I talked about in class as far as relate this again to the reciprocal function. And the important thing is when we have a linear polynomial over a linear polynomial, that is really actually just the reciprocal function written in rational function form. So to rewrite this as a reciprocal function, all I'm simply going to do is apply division. So x minus 2 divided by x minus 3. X goes into x 1 time. 1 times x is x. 1 times negative 2 is a negative 2. I will subtract. And I did this in my class just so students can go ahead and get used to. This would be a negative 1. Now again, well, I did this in class so my students can kind of see the relationship here from the reciprocal to the rational before we start getting into more rational functions. But once we go through the techniques down here, you could easily get them applied here. But it's important. We can apply them here, but not to this one because it's not written in that rational function form. It's not a polynomial over a polynomial. You have this minus 1, which kind of messes that up. Anyways, moving on to my next one, so that's plus, so negative 3 minus a negative 2 is a negative 1. X does not go into negative 1, so that is my remainder. And if you remember from division of polynomials, we want to write the remainder over our divisor, x minus 2. So this function can really be rewritten as 1 plus a negative 1 over x minus 2. So what that tells me is we could actually even write this one more time. Let's put this 1 as the k instead of the k being in front. Let's put it out. Let's put it in the back. So we'll have a negative 1 over x minus 2 plus 1. Okay, and so what this tells me is, all right, so now my transformations, I have a reflection about the x-axis, but the reciprocal function is odd, so that's actually not going to matter. It could be a reflection about the x or the y-axis, but it's not going to affect. All that's going to do for this reciprocal function is now, put the hyperbolas in these, over in these kind of two quadrants. But it doesn't affect the asymptotes. That's the important thing. The only thing that's going to affect the asymptotes here is this h, which is now being shifted 2 units to the right, as well as my shift k, which is my shift up 1 unit. So my new vertical asymptote, here is going to be x equals 2. And my horizontal asymptote is now going to be y equals 1. So very similar to what we had over here. Now to find the x and the y-intercepts, I'm actually not going to use this information anymore. To find the x-intercept, I know that y is equal to 0, right? So, but rather using this form, I'm going to use my rational function form because what I'm about to show you is going to save you a lot of time when trying to find the x-intercept. And I'll work it out this one time, but then I'm going to use a shortcut for the other problems. So if I replace this y with 0, I have 0 equals x minus 3 over x minus 2. Now now I again need to solve for x, and I have this x minus 2 in the denominator. So again, I got to get it off the denominator, just like I did over here. But the difference is, here it's equal to 0. Here I had to equal to 1 because I had to get that 1 to the other side. So what's nice about this is when you have a rational expression equal to 0, and you're trying to when you have a rational expression, you're trying to set it equal to 0. When you multiply that by that denominator on both sides, that divides to 1, and that goes to 0. So what really you're obtaining is the numerator equal to 0. And that works every time. It doesn't matter what is in my denominator. I mean, I could have like pi here. It doesn't matter. You're going to multiply by pi, that divides out, and that goes to 0. So it doesn't matter what's in your denominator. If you need to find the x-intercept and you have it in a rational function form, just set the numerator equal to 0. So therefore, x is equal to 3. For the y-intercept, we have some tricks as well when it's in rational function form, right? A polynomial over a polynomial. Again, in this case, you're going to plug 0 in for x. So we have 0 minus 3 over 0 minus 2. Well, what's important about this is wherever there's an x, that's always going to be 0, right? Even if it's multiplied by a number, it's still going to be 0. So what you notice is the only thing that's not going to be 0 is your constants. So to find the y-intercept of a rational expression, what you're simply going to do is just take the constant over the constant. Now again, be careful. This is negative 3 over negative 2. So this 4, that reduces down to a 3/2. Okay? All right, so now let's kind of get into some rational functions that we're going to have to apply the horizontal asymptote test. And I'm not going to go write them down for the time, but that was one thing we talked about in class is, first thing is comparing the degrees of our polynomials and obviously simplifying them. So first thing I'm going to do when I look at this function is in this one, I'm going to expand it because right now it looks like the degrees are the same. But as I expand x plus 2 squared, that's x plus 2 times x plus 2, which is x squared plus 4x plus 4. What I notice is that the degree in the denominator is larger than the degree in the numerator. And if you remember the degree in the denominator, when it's larger than the degree in the numerator, the horizontal asymptote is at y equals 0. Oh, let's just write there. I'll just write y equal. I'll just say horizontal asymptote test. Y is equal to 0. So I'll say horizontal asymptote, y is equal to 0. For the vertical asymptote, since we can't divide this into there like we did in this other example, we're going to have to understand the vertical asymptotes from what we remember in like our previous example of functions. And remember, the vertical asymptotes occur for the discontinuities of the denominator, basically the values that make the denominator equal to 0. Now remember, if they divide out, then it's a whole. So we got to be careful. That's why I like to factor things out or just make sure that nothing divides out with the numerator and denominator. And I don't remember if I put in one of those problems into this homework, so I got to make sure I check it as well. But again, if I want to find the vertical asymptotes, all I'm simply going to do in this case is just set my denominator equal to 0. Now, should I use this factored form or the expanded form? And it doesn't really matter. I'd prefer to use the factored form because here, all I need to do is take the square root of both sides, and basically what I'll have is x plus 2 is equal to 0, so then I can say x is equal to negative 2. Okay, now to find the x-intercepts, or find the x-intercepts, again, remember, just what I found here, just take the numerator, set it equal to 0. So x minus 4 is equal to 0, so x is equal to 4. To find the y-intercept, just take the constant over the constant. But again, that's not the constant. This is the constant. So it's negative 4 over positive 4, which is y equals negative 1. All right, on to the next one. There's a dark green. So again, I'm going to want to factor this first because I want to see if there's any holes, anything that divides out. So here I can factor out a 2x. By factoring out a 2x, I'm going to be left with an x plus 3. Over here, I'm going to factor out a 3, and I'm left with a x squared plus 2x plus 1. Okay, and you can see this factors down to a perfect square trinomial. We also notice that the powers are the same, or the degrees, I'm sorry. The degrees are the same. So the horizontal asymptote says when the degrees are the same, then y is equal to a over b, where a represents the leading coefficient of the numerator and b represents the leading coefficient of the denominator. So I can just kind of look at here and say degrees are the same, leading coefficient over leading coefficient. So my horizontal asymptote test says my horizontal asymptote is y equals 2/3. Okay. For my vertical asymptote, I'm basically just going to set my denominator equal to 0. Now, the nice thing about having that 3 factored out is that does not affect my solutions. Okay, that's just a scalar, so I can divide that 3 out. And then I'm left with x squared plus 2x plus 1, which I recognize to be a perfect square trinomial, so therefore I'm just going to factor that as a binomial squared. And then again, I can take the square root of both sides, subtract 1, x is equal to a -1. Now to find the x-intercepts, again, I'm just going to set my numerator equal to 0, which I already did. Like, that already factored it. So why don't I just take the factored form rather than refactoring it, doing that extra work? So I'll have 2x times x plus 3 is equal to 0. I can now apply the zero product property, and therefore I will get x is equal to 0 and x is equal to a -3. Again, when you set 2x equal to 0, you'll divide by 2, which still get x is equal to 0. And then for the y-intercept, this one's interesting because it's coefficient over coefficient, right? Or sorry, constant over constant. Well, we don't have a constant here. Well, again, think about it. If you plugged in a 0 for all your x's, 0, 0, 0, 0, you're going to have a 0 over 3. So obviously a 0 over 3 is just going to be y is equal to 0. Or you can think about it, if there is no constant, you could just put a 0 there, right? There you go for that one. All right, next one. You can see here now that the variables, again, are the same. So therefore, my horizontal asymptote is a ratio of my degrees. Now, what's important about this one is, actually, let's see, what else could I do? I'll just use black. The coefficient of x squared, remember, is going to be 1. So my horizontal asymptote is going to be at y is equal to a -1/2. Okay. My vertical asymptote is going to be at, interesting on this one. So my vertical asymptote is going to be my denominator set equal to 0. Now, again, I want to make sure, can I factor, can anything divide out? And when I'm looking at this problem, I see this numerator is non-factorable. So I don't have to worry about anything dividing out using the whole. So not going to worry about that case. But when I go ahead and solve this, I end up getting, when I subtract the 8, I get a -8, and then I divide by -2, I get an x squared is equal to 4. Minus 8 divided by -2, positive 4. So therefore I take the square root and I get x is equal to plus or minus 2. And please be very careful. Please be careful with the plus or minus, because if you drop it off, you're literally leaving off a vertical asymptote. And if you were to graph this, especially in the Desmos, you would see there are 2 vertical asymptotes, not 1. So that's why that plus or minus is so important. X-intercept. So I decided I wanted to do a fun one for the x-intercept. So I set my quadratic equal to 0, and I realize it's non-factorable. So if it's non-factorable, that means I need to use the quadratic formula. Crap. Now, when using the quadratic formula, again, like if it's non-factorable, we got to be able to check to see what our x-intercepts are. So we're going to need to solve using quadratic formula. So let's see how quickly we can do this. So that's going to be 1 plus or minus the square root of -1 squared minus 4 times a times -1. I think, is this the same one I did in class? And that would be 2 times a. So -1 squared is 1. -4, yeah, it's square root of, yeah, that's the same. It's not the same problem, but I did the same thing as class. So for all my students, you luck out. So let's put the answer here. So x equals 1 plus or minus the square root of 5 divided by 2. Okay, so we're just going to have some irrational x-intercepts, but that's okay. They don't always have to be integers. The important thing, though, is if you have if your discriminant is negative, then obviously you would have complex x-intercepts, and which would not show up on a graph. So therefore, we would say there are no x-intercepts. So that is another possibility that came up in our class today. The same thing for vertical asymptotes, right? If this was like a positive 2, then you'd be taking the square root of a -4, and therefore you can't take the square root of a -4 in our real number system. So therefore you wouldn't have any real vertical asymptotes. They would be like imaginary numbers and wouldn't really make sense as far as on the graph. So just be careful of that for the intercepts and the vertical asymptotes. You can have complex. So therefore you could have values where it wouldn't work in the real number system. So therefore the vertical asymptotes or x-intercept just wouldn't exist. Maybe this one, okay. So again, in this next system, you can see here I can factor out a x. So by doing that, I get an x squared plus 5x plus 4. I can see that is definitely factorable, so I'm going to want to factor that down again. But then I decided to do something else that is non-factorable, so I'm making myself do the quadratic form again. So let's just go and check the discriminant here. Remember, the discriminant is b squared minus 4 times 8 times c. So that's going to be a -1 squared minus 4 times 1 times 1. Okay, sweet. So that's going to be a -3. And that's important because remember, the discriminant is what's under the radical, right? So under the radical here, I'm going to have a -3. That means that there are no real numbers that make this denominator equal to 0. So that will be important. So once I kind of recognize that, I'm saying, hey, you know what? Let's just go and check that out. One thing I notice here is that via the horizontal asymptote test, the degree in my denominator is less than the degree in my numerator. So the horizontal asymptote says there are no horizontal asymptotes. So horizontal asymptotes, none. Vertical asymptotes is also none. Why are there no vertical asymptotes? Because when I set my denominator equal to 0, which I didn't show my work, x squared minus x plus 1 is equal to 0. When I do the quadratic formula, x is equal to 1 plus or minus the square root of -3, right, divided by 2. So therefore, you can see it's not going to be in the real number system. So there's no vertical asymptotes. For the x-intercepts, I'm just going to set my numerator equal to 0, and I'm going to continually factor this down. So that would be x times x plus 4 times x plus 1 equals 0. So therefore, x is equal to 0, x is equal to -4, and x is equal to -1. So a lot of x-intercepts, right? 3 of them, kind of cool. And then for my y-intercept, I don't have a constant now in the numerator. Oh, actually, I already did an example like that. I probably should have changed it up. So I have 0 over 1, so my y-intercept is y is equal to 0. Now, one thing I'll probably do, what I usually like to do is add the link to Desmos, which I should have done. I apologize for that. But I do like to, I did that in the guided notes. If you looked at the guided notes, you can see the examples. Each one I do, I show what the graph is. And again, just to kind of recap on all these problems, if I was to actually graph these, if I was going to say, hey, graph these first 2 examples, I would just use transformations of the parent graph. So I'd basically have the parent graph, understand my transformations, and then shift the graph. For the next 4 problems, I would be doing this exact same work, but then what I'd do is I would identify points to the left and to the right of each vertical asymptote and plug them in to identify the y-coordinates. And then I'd plot those points. And based on what shape I could get out of those points, I would either continue to do more points or I would just sketch the points that I had to create the curve of the graph. And use obviously the x and the y-intercepts as well as coordinate points. So, all right, I'm just going to take a quick little break here. I'm already over my time limit, but I do want to get to these multiple choice questions. They shouldn't take me too long. So if you want to go ahead and work on these, that's awesome. I'll just go ahead and stop in and say hi to some of you guys that have decided to join me in. Nayland says, I got a 12 on the ACT. Let's go. Yeah, maybe not. Let's see. Retro Supreme. Who is in his class? I don't know if any of my students are in my class. They keep on asking me to do it a little bit later, though. But I didn't want to do it tonight. I didn't want to be up to that lore. So Daisy says, does this save as a video? Yes, Daisy, this does save it as a video. All of my live streams that I do, if you go right to like my channel homepage, and if you scroll all the way down, it says my like latest live streams, and basically you can follow me from everything that I've been doing this whole year. So far this year, we have covered functions, polynomials. Now we're in a quick little mini unit of rational expressions or rational functions. And then in about 2 weeks, we're going to get into trig. So we'll get into trig, analytic trig, vectors, and what else? We'll get into vectors, polar, parametric equations, conic sections, and then we'll get into limits at the end. So we're kind of getting to that halfway point, getting pretty close. All right, guys. Well, thank you so much for joining in. I'm just going to kind of wrap this up. And as I mentioned at the beginning of the stream, I'm kind of running a little bit behind. So I apologize for not being able to kind of slow down in talking, as well as being able to answer many of your questions for you guys, especially if you have, work. But I will let you know that, let's see, I will definitely be going live next week as well, probably on Monday. So if you do have some questions or if you just want to join for that live stream, I don't know when, but I like to have them planned so you guys that when you get on YouTube, you can see when I am going live so you can join in. So I'll just try to make sure I can get that confirmed for you guys at least the day of. All right. So, did I do the slant asymptote? No, I forgot to. Crap. So again, we got to identify the slant asymptote here. So what we got to do there is do long division. So again, the slant asymptote is just x squared minus x plus 1 is just the y equals the quotient of our division of these two polynomials. So that's x cubed plus 5x squared plus 4x. Okay, so x squared goes into x cubed, x times x squared is, sorry, let me bring that up. X squared, x times negative x is a negative x squared. X times 1 is a positive x. Subtract. That's supposed to be a cubed. That goes to 0, and I'm left with 5 minus a negative x squared. So that's going to be a positive 6x squared. 4 minus x is going to be a positive 3x. X squared goes into 6x squared, a positive 6 times. 6 times 6x squared is a 6x squared. Ooh, getting right at the end of this paper. And then x times negative x is a negative x. And then x times 1 is, x squared. Wait, what happened to my x squared? No, it's 6. 6x squared, negative 6x, and then a minus 6. Okay. It doesn't matter, whatever. That's going to go to 0. When I subtract these, and I'm going to be left with a 4x, okay? Or I can say 4x. Now, the important thing is x squared does not go into 4x, so that is my remainder. But if you remember that when we're doing this oblique asymptote, we're just confirmed with the quotient. We can disregard the remainder, because when you take the remainder over the divisor, as our values get larger and larger, that rational expression approaches 0. So it basically becomes insignificant. And it's easy to kind of look at the graph and you can kind of see how that works. And in my class, we kind of went over that. So anyways, the slant asymptotes would be x plus 6. So that prompted me again. It's like, oh, well, let's do another slant asymptote. So again, if we're trying to find the slant asymptote, we're just going to use long division. Okay. X goes in x squared, x times x is x squared. X times negative 1 is a negative x. Now, again, I don't have a placeholder here, so I'm going to plus a 0x. 0 minus a negative x, so that's a double negative, so that's just going to give me x. X goes into x one time. I know if I do this again, I'm going to get a remainder of 0, so I'm just going to look for y is equal to x plus 1, which is right there. Next example says, determine which of the rational functions given below has the following features. X-intercepts, -1 and -4. So that means the numerator is going to equal -1 and -4. So if I were to set each of these numerators equal to 0, I would have x equals -1 and x equals -4. So that one works. That one doesn't. That one doesn't. and that one works. Okay. So let's see, y-intercept is 1/4. Now that means that would need to be expanded to 4/1. The y-intercept is 1/4. So let's go ahead and expand this out. So if I was to expand that out, that'd be x squared plus 5x plus 4. This would be expanded to x squared minus 8x plus 16. Okay, and if you expand this out, you would have the 4/4, which would equal 1. All of these have a y asymptote of 1 because the powers are the same and the leading coefficients are 1, so everything covers that. Vertical asymptote here, everything covers that, or at least these two cover that. But the y-intercept, remember, it's constant over constant, so that's why A is our answer. Given the equation of the horizontal asymptote, if any, of the function. So again, we look at the degrees, make sure it's in standard form from highest power descending down. You can see they both share 2. And then again, so the horizontal asymptote says it's just going to be the ratio of the coefficients, 8/7. So that would be answer B. Given the equation of the oblique asymptote, if any. So again, I decided to do another oblique asymptote. So let's go ahead and divide. So x plus 4 divides into x squared minus 9x plus 2. All right, x goes into x squared, x times x is x squared, x times 4 is a positive 4x. Okay, remember, use parentheses and subtract the rows. So that goes to 0, so I have a -9, so you owe me $9, and you borrow $4 more. You now owe me $13. X goes into -13, and you can see automatically there's our answer. If I continue doing that down, I'm going to get a remainder. So there you go. There's my answer A, and then I just did a little fun problem that you can go ahead and work on. So you are very welcome, Cam, for your help. And this was asking when I'm going to get my Fortnite stream. I don't have my Fortnite stream. Sorry about that, guys. My nephews do, and they enjoy going on Fortnite. But I am way too busy doing these live streams, kids at home, and then making some more content. Which I just sent out a factoring worksheet. If that is something that any of you are struggling with factoring, I'll just do a quick little pitch for here. Doesn't cost any money. It's completely free. I just sent it out to people on my email list. And it is something that I have been getting a lot of feedback from my students as well as people online that it's really helped them out. And it's very simple. It's not like anything magic. It's just a whole bunch of practice, but it's designed practice to really help you factoring. So if any of you are interested in getting some factoring help, like that's something you really struggle with, just make sure you go to my website. My website is currently being fixed as well right now. But just feel free to get on my website, email me, let me know. I'll be more than happy to send you a copy. It is awesome. It is awesome to see a lot of people that have been struggling with factoring for many, many years to be able to improve upon those skills. But anyways, I didn't want to get too much of that. That's only for those of you that want that issue. I will look into getting into the stream on next Monday. But otherwise than that, guys, I am going to sign off early. So appreciate you guys being here, and we will check in. What was I going to say? I don't know. I'll see you guys next time.